hopefully have a decent idea now of what a collection is, what the purpose of it is, and maybe a little bit about the implementation underneath of it. Before we actually get to a demo, I want to talk about some of the important concepts and how do we code using collections. It shouldn't be a totally new idea. I did cheat a little bit and show you a collection. I didn't really explain it much. One of those things, like maybe you just used it and didn't think about it. Maybe you thought, what is this thing? Hopefully now you are starting to see what that was that we went off and used and how we can manipulate and use it. So the first thing I want to point out, and I've mentioned this already a little bit, is making sure that we reference a collection using the idea of replaceability. So we want to make code easy to swap out one thing for another. We talked about this a little bit as we created a component. If we wanted to swap out the idea of I have a file, make it now into a database, make it now into a web service, I should be able to do that using interfaces. And the same thing is true with collections. So as I'm working inside of a collection, when I'm creating a variable, when I create a variable, it should be a local variable that points to a collection. It should be a parameter that points to a set. It should be a local variable that points to a list. I should not see on the left-hand side of these assignments, on the creating of variables, something that says array list or hash map or tree set or any of those detailed ones. I should be dealing with an interface up here. Again, that allows me to swap out the implementation. And furthermore, I want to try and pick the most abstract I can live with. So if I don't need to deal with the set, then put a collection here. If I don't need the features of a list, then put a collection here. But if I know I'm going to iterate through these one at a time, make it a list. So I want to have that interface align with the functionality I'm going to be using. So I want to use a collection then when all I care about is a bunch of data. You're handing me a bunch of data, I'm going to look through it one at a time, give me a collection. I want to use a list when I care about the order, and more importantly, when I'm manipulating the order. And I want the set, obviously enough, when I want to guarantee one of anything inside of there. So by using these interfaces, I can swap out any implementation I want to. So I can make something that prints out a list of objects. And if by making it a collection of objects, I can do it whether it's a list or a set or any of those subsets inside of there, sub implementations inside of there. Our code's more flexible and I get more reuse out of my code by using the highest level type I can get away with. So you can see I can make a collection C and assign it to a tree set. No trouble. As long as it's an instance of a list or a set, I can store it as a collection. I can make a list L, which is an array list. And this one right here is the one you'll probably use most of the time. And a set S is equal to a hash set. I can take the collection C, and I can assign it to the list, or I can assign it to this set. Anything that's a list is a collection. Anything that's a set is a collection. This goes back to inheritance rules. It's nothing new or unique we're creating here, but I just want you to see the way this inheritance works. If I need to know what a certain collection is, I can ask if collection C up here is an instance of a set. And it's going to tell me true or false. And if it is, I can take the C and cast it back into set S. I can pass it back along. Do the same thing with list. Instance of is an operator in Java that allows me to ask, is this object something that implements or something that is an instance of this interface or class over here? And if it is, I can treat it as such, and this I can cast it and use it as such. So there's a little bit of assigning and casting and creating of these things. They're pretty easy to work with. Again, I mostly define them one time, but then I can go and use them from there. So the basic operators on all collections, I can do add to a collection, a list, or a set. For a list, I can add at a specific point in time. So I can add into 0 inside of there. In any collection, I can say add all. So I can take all the elements of the list L and add them to the collection C. And so let's say that C is its own collection. I take C and add foo. I take L and add bar. S and add baz. And then I go to L and add in start. So now L contains start and bar, C contains foo, and I go to C and add all of L, so I take start and bar and add them to foo, and so C should have 3 elements inside of that, which is what our report does. It says down there. So again, manipulating the collections, not too bad. Adding in, pretty simple. Adding in at a specific location, I just tell it what the location is by index, and I can take all of the contents one and add it to another. That's the way that works. If I did add L, it would attempt to add the list L to the collection. That may or may not work depending on how the collection is defined. We'll see that as we go.